Okay, today we're going to talk about the refrigeration system, and on the board there are a lot of schematics, and also the write-up is there. I'm going to walk through all that information in a step-by-step way, and we're going to take our time to understand what are the changes that are taking place. Refrigerator, the working fluid is freon. So when I'm talking about the medium is freon. So it goes through some phase changes and things like that. And when it doing it, how the pressure and enthalpy diagram is changing, affecting it, and also temperature and entropy diagram is being affected. So with that, let's get started. So what we have is first of all, enthalpy equal to internal energy plus PV energy. The two components. Enthalpy consists of internal energy and pressure and volume energy. So enthalpy is one means to determine the size of the various components. That means we are using condenser, evaporator, compressor, and things. So that is, we need to know how much refrigerant the system needs so that we design it according to the requirements. So that's what the um, um, enthalpy comes handy. And how are we doing it? How much refrigerant should contain based on how much energy it can be absorbed. Because on the size of the room, size of the house, you decide what type of refrigeration system, what capacity you need, and the capacity is dependent upon how much refrigerant the system should use. So basically, you're absorbing energy from the environment, from the room, for example, this room, and then rejecting it. That means you're taking this hot air, throwing it outside the environment, into the outside area. So that's how you are cooling this place and removing the heat and dumping it outside. So to transfer that internal energy, I'm talking about this internal energy, from one area to another by making the refrigeration temperature higher or lower than the surroundings. So that means you're just basically playing with the refrigeration temperature. One time it will be higher, one time it will be lower, and using that you're manipulating the system, and you're one area you're absorbing the internal energy, other area you're dumping the internal energy. So um, and how you do enthalpy change, it is controlled by IE and PV. And as I walking through the diagram, I'll talk about it. And so just I want you to remember at this time, we're going to talk a little bit more. Condenser and evaporator controls the amount of internal energy. Just remember that. Condenser and evaporator. So our condenser is here and evaporator is there. And also on the schematic of it, working schematic, condenser is here and evaporator here. So that's what, in those areas, what are we doing? We're changing the internal energy. While compressor and evaporator were controlling the PV energy. Because remember the two components, internal energy, PV energy. By compressor and expansion valve, where are the compressor? For example, compressor is here and expansion valve is there. And here the compressor is here, expansion valve is on this side. So using in those two components are they manipulating the PV energy. So this is how the system works. So at least you got a general idea how a refrigeration system works, and how enthalpy plays a big role in understanding this energy transfer that is taking place. So let's go to the basics now. So at least we talked about a schematic. So you have a compressor, and you have condenser, an expansion valve, and the evaporator. So in any refrigeration system, we need four components. Those are the main four components we're talking about. Okay, so one thing also you need to remember is condenser is where your the hot air and hot heat is thrown out into the atmosphere. That's why the arrow is showing outside. Whereas evaporator, where in the room the cold air is coming in, that is coming from where? Evaporator. That means you are taking the heat of this room and getting it absorbed into refrigeration, and that's what you're taking, that heat, and dumping into the condenser to reject it. So here's a heat absorption, the other one is heat rejection. Is it clear that so far? Okay. So let's talk about pressure enthalpy diagram and also temperature entropy diagram. They're all connected, and when I'm going through that, we'll go steadily component by component. Remember, we talked about 4 components. We're going to focus on those 4 components. For example, let's start with always better, is easy to understand, is starting from the compressor. Compressor is a device, basically it is compressing the air. It's not liquid, it is compressing air. So that means whatever is feeding into the compressor has to be in a gaseous form. So that is, so for example, if you look at the PV diagram, the point here is a low pressure system. This is a pressure, and this is a high pressure system. So you are feeding with a low pressure, number one, and also it has to be gas. So that means whatever coming from the evaporator has to be a low pressure and a gaseous stage. Okay, got it. We take that gas and compress it. So what you're doing in compressing, you're compressing it. Compressing means you're shrinking the volume. So that's exactly what is taking place. So you are affecting this component of the enthalpy. Remember the 2 components, you're affecting the same. So as a result, what is happening? So when you compress anything, volume goes down. Yes. So volume decreases, and when you're compressing, the volume goes down, the pressure has to go up. So the pressure is increasing. So that means this portion of the energy is increasing, basically, right? So so that's what's happening here up to this point. So from there, we are now coming back to this. In this diagram, here is your compressor, and you're compressing. Again, before we go a little bit too much detail into it, I just want you to understand the curve. I should have done it before, but it is still no harm to explain it. Pressure volume. This is a a diagram of a refrigerant system, where this portion is a liquid line, saturated liquid line, and this is a saturated vapor line. And this region, the whole region on the right hand side, is a superheated region, and on the left hand side is a subcooled region. So they have 2 different phases here, right? So that's all. Now related to this here, same thing again in TS diagram. On the left hand side is a saturated liquid, this line, and this would be a saturated vapor line that is there, right? So when I'm taking low pressure gas, compressing it, the temperature of the it is going. So remember this TS diagram, the temperature is going up. Again, it also is a constant entropy process. This is a constant entropy process. So far, so good. Okay, we have got to the point. So we also talked about, when you, by the time it reaches this stage, you have low pressure, low volume, high pressure. From here, we're running through the condenser. Condenser is nothing but a heat exchanger. Evaporator is also another heat exchanger. So what you're doing is the high temperature, high pressure gas that is going through, it is you're rejecting the heat into the atmosphere. So that's why you see that heat rejection taking place here. So while you're doing that, from high pressure, high temperature, running through the compressor coils, and you're rejecting the heat, there is a phase change taking place, because remember, it's in a vapor state, and it is turning out to be liquid. By the time it comes out of the condenser, it's a saturated liquid stage already, right? So what exactly happening? So when it comes out, it still be high pressure, yes, and regular temperature. Oh, what happened here? From there, we came down and we're here. Temperature dropped, right? So that's what we're calling regular temperature. And then, so in that one, now if you look at our the enthalpy equation, what exactly is changing? Pressure, there is internal energy. This energy, because of the phase change, it is going up. So you have increased here one component, and you also increase here. So now that's where the stage this liquid is. So from there, you go to the expansion valve. Expansion valve is a device, a high pressure low temperature liquid is expanding, and when you expand, what happens? The pressure drops, right? So that's exactly temperature also dropping along with it. Is becoming much colder from here to here. So that is an expansion valve. So exactly when you're coming out of the expansion valve, the thing to remember is decrease in PV energy. This energy is decreasing because pressure is decreasing, right? So you have an increase in volume, but pressure is what controlling this component of this one. And then it becomes low pressure, cold liquid. Yes, it has from there, it has temperature has dropped even more, and it become a very cold liquid. Um, uh, and um, and also gas, because it's not purely a liquid, it is a mixture of liquid and gas. That's the stage when your expansion valve, when it comes out. And then what happened? You're going through the evaporator process. So the evaporation is, that means now you're the freon is in a um, semi liquid stage, gas and vapor, and a low pressure. It absorbs all the heat from the room. And that's why when you put a fan behind the evaporator, it blows the cold air into the system because it's absorbing all the heat from the room. And then the cycle continues. So, but when it comes out, what I want to tell you is there is a phase change taking place from liquid. Remember, it was semi liquid and gas, and now it becomes totally gas, and exit as a low pressure warm gas. And then because it absorbed heat of the room, and it has to warm, right? And that's what exactly what happens. And here again, we are back to this stage, and that increases in internal energy. So that is again, so now by the time you reach here, now what you're doing is you're compressing it, and that I mean internal energy, this increase in internal energy, and by compressing it, and you're increasing the PV energy. So the cycle continues. And this is, in one diagram, you could tell the whole story how the refrigeration system works. And also the key component is understanding, hey, there are 4 components to it, number one. Number two, there are 2 areas where the phase change is taking place. And also, we also said in compressor and expansion valve, what would you say here? Condenser and evaporator controls the amount of internal energy, right? And then while compressor and expansion valve controls the PV energy. So one area pressure goes down, other area pressure goes up, and that's how you are manipulating this equation and using it for your advantage. That means you're taking the heat from the room and dumping it outside. That's simple as it is. And I think the most, without even seeing anything, you should be able to draw. One thing, number one, is how to draw PV diagram. First of all, what is a schematic? Always start with a compressor, go to condenser, expansion valve, evaporator. Cycle is complete. And having this one, then connect this to this diagram, PV diagram. So how the compressor is going up, down, and you can relate. Whenever it's here, you can say, hey, we know low pressure gas is coming and is becoming high pressure gas. You should know that. So, and then from liquid to condensation, changing the phase means from gas to liquid is becoming, right? And then expansion, again, the liquid and vapor, but here by the time it comes out, another phase change, we're completely gas when it comes out. So this is the process it goes through, and I think if you understood this mechanism, you had a pretty good idea how the refrigeration system works and how the phase changes takes place, how the pressure and enthalpy is changing, and also temperature and entropy changing. Okay, that's it. Thank you.